Alrighty, so welcome everyone to April Innovation Webinar. My name is Liz Mann and I'm the Project Coordinator for Major Innovations employed by Dairy Australia, but working with the Victorian Dairy Innovation Agreement, or what we call VDIA. The VDIA is a newly formed group that's a joint venture between Dairy Australia, Gardner Foundation and Agriculture Victoria to oversee the major dairy research projects of Dairy Bio and DairyFeedbase. This month, we are joined by DairyFeedbase researchers, Dr. Liz Morse-McNabb and Dr. Anna Thomson, and we are so pleased that they can join us, which is very exciting. For the past 5 years, Liz and Anna have been working on the Pasture Smarts project, which forms just one of 5 projects that make up the work that is the DairyFeedbase research. So welcome, Liz and Anna. I'm so pleased to see you both, and thank you for being willing to join us today to talk about the research you've been working on for a while.
No problem.
So with what's happened in the last 5 years, Liz and Anna, it must feel like a lifetime ago that you actually started working on this project. If we go right back to the beginning, what was the problem that you were setting out to solve at the beginning of the project all those years ago?
Thanks, Liz. Thanks for having us here, and apologies, I'm on my mobile phone today, so the technical challenges are minor but solvable. Look, yeah, it's such a long time ago. It feels like a lifetime ago. It really does. But essentially what we were trying to do was, and the issue's still there, that pastures are a really cheap source of feed, but it's underutilised. And that's partly because it's just difficult to use. There's digital tools out there that are just difficult to measure and manage that pasture utilisation. And, you know, it's so important as the all of our feeding systems are becoming more complex, and the whole, our daily activities are becoming more precious to us. So there's a real need for that near real-time measurement of pasture mass and nutrient characteristics to enable that optimal feeding. So we wanted to look at a suite of technologies that could be used practically on farm, and we've worked at that paddock level, no plots. But Anna might also have a comment.
Yeah, I mean, I think if we think back 5 years, and even still today as well, a lot of farmers are using visual observation of their paddocks, and that does take time out of the day to visit the paddocks and see how they're going. And also there's only a certain degree of accuracy that can realistically be achieved by just looking at something. Even looking at tools like rising plate meter, surveys show that not too many people are actually really using these tools. The ones that are, well, they do report that they're very labour intensive, because you do have to walk around your paddock using the tool manually to obtain a result. And even then, it's only one average for your whole paddock. We were really interested 5 years back to see if we could move more to mapping of biomass. And we saw that there was sensors available and coming onto the market, and more all the time, that were capable of doing this job. They just needed the proof of concept testing and calibration for our local environment. So, yeah.
So you're right, pasture is our cheapest source of feed, and being someone who's worked in the Tassie industry for so long, I'm quite passionate about pasture and its utilisation, and you know, it is the basis for our industry. What is it exactly, you've talked about sensors, what is it exactly that you've looked at to speed up that process of measuring and managing our pastures?
So like Anna mentioned, that we've focused on sensors that can work at that paddock level. So it's not been plot-based work, it's all been thinking practically about how to use these things on farm. So we've got a bit of a suite of sensors. So we've used a sonar sensor that's mounted on a farm buggy. And so sonar uses sound waves, and that's what we call an active sensor, because it emits a pulse and then we record the time it comes back to us. We've also used a fixed 6-band sensor that's mounted on a pole, and that's for us mostly to look at changes over time. So it's not something you'd use necessarily on farm so much, but it helps us understand those seasonal changes. We've also looked at a 5-band multispectral sensor mounted on a UAV or a drone, a 12-band multispectral sensor that was mounted on a satellite, so that's Sentinel-2 satellite to be specific, and handheld hyperspectral sensors. Now, I'll let Anna go into the hyperspectral stuff, but just to clarify, multispectral usually means less than 20 bands, and the bands are broad, whereas hyperspectral will commonly have hundreds of bands. and they're narrow. And so hyperspectral sensors are all about that sensitivity to other more specific traits.
Yeah, just to elaborate on that a little bit, my own area of interest was very much in the nutritive characteristics of pasture. So I don't believe that we should only be looking at biomass. The nutrient, especially when we think about dairy production, which is so driven by the nutrition of the animal, we absolutely have to consider the nutritive characteristics of pasture. So that's why I was interested in these hyperspectral sensors. They are so detailed in the information that they give. They can basically tell you about the chemistry of the plant, which is really amazing when you think about it. You can't just visually look at something and tell me how much protein it has, but these sensors can. So really, really fascinating technology.
Yeah. And the interesting thing too is in talking about this technology, it's not just ryegrass that you've been looking at over the last 5 years, is it? You've looked at others. We probably should be talking more forage than just ryegrass, really.
Yeah, I can take that one, Liz. So we did start out by looking at perennial ryegrass, especially from the first sort of years 1 to 4 of our 5-year program. We're heavily focused on perennial ryegrass. Obviously, we can't ignore perennial ryegrass. It's very much a predominant feed around the state. But as the work has progressed, and we've definitely had more and more interest in alternative species, looking to the north of Victoria, for example, there's now very heavy use of alternative species. So we didn't want to just stop at perennial ryegrass. We actually finished our 5-year program with a big experiment to test whether the calibrations that we actually made for perennial ryegrass were transferable to other species, or whether we needed to perhaps calibrate again for new species. Like a big question in my mind is just how many times do we have to keep calibrating these technologies, right?
Yeah.
Because it takes a lot of work. And if we can use the same calibration data sets again and again with different species, that's obviously powerful. So yeah, we have been working on a project about that, and some of our findings show that it's not always appropriate to apply a perennial ryegrass algorithm that you've developed, a calibration for to other species, but it is possible to make broad calibrations that include samples of lots of different species and apply those. So you don't have to necessarily calibrate for every single new species that comes onto the market if you have broad-based calibrations. That said, we did find that often the greatest accuracy was achieved by having specific calibrations for specific species. So really interesting piece of work that we did there. That covered cocksfoot, red clover, chicory, a mixed paddock, and also perennial ryegrass in that study. So really interesting.
So with that, like you're talking, different sensors that we've talked about. Have you gone and built something specific? Like you talked there, you've also had to calibrate for this particular, you've had to calibrate for ryegrass. You've also looked at what you need to for those alternative forage species. Have you had to go and build a specific sensor, for this task, or what have you done?
No, we didn't. We've just basically bought off the shelf sensors. So we've focused on the wavelengths that these sensors can image across. We've looked at the bandwidths that they image and their application rather than actually building sensors. We essentially, the whole point of it was to find out which sensor would work when and where. So it's pretty hard to build something you don't know what you're trying to build. It just didn't seem logical to start building something we didn't know. So we've just used what's out there.
Excellent. So what have you used? You mentioned before you've got satellite. What were they again? There was satellite, there was on bikes, there was all
sonar, UAV.
What was that? Sorry, Anna.
Sonar and UAV.
That's
yes.
it. That's it. So you've also mentioned, so you're working with these sensors. Is it possible to read nutritional value, Anna? Like you're quite passionate about that. Can you do it?
Yes, yes. So I think we've actually done a number of experiments on this. We started out with some pretty basic proof of concepts, like you say, can we do it? It is a bit of a holy grail for anyone working in pasture, I think, to be able to get a real-time read of nutritive characteristics. And even right back in our first experiment, which was, I think, 2019, we did do some proof of concept that showed, yes, you can, to within a certain level of accuracy. And at that time, we were working with a very expensive sensor that was basically an adaptation of what you might find in a lab for doing nutritive characteristics. So we weren't necessarily suggesting that particular sensor was farm ready. It was more just to show, can we do it? And the answer was yes. We then moved on from that experiment, and we saw that there was obviously a need to find out if some more farm ready sensors could also tell us nutritive characteristics to within an accuracy that would be useful. So we went on and assessed a range of 3 kind of off-the-shelf handheld devices for their ability to tell us nutritive characteristics. And the good thing was that all of those sensors showed promise. There were some that were more accurate than others. In fact, the most accurate one was a really cool piece of tech, which was a hyperspectral camera. Hyperspectral cameras are like some of the newest tech in the hyperspectral space on the market. Used to be that hyperspectral sensors were just, you get one reading for the point that you're looking at, and it's just a line of data. But these hyperspectral cameras are actually taking images, and there's hyperspectral information in every single pixel of the image. And that in one of our most recent experiments has proved really, really powerful, because you can actually take out anything that's not the material of interest in the image. You can remove bare soil, for example, or any noise coming from that sort of unwanted material. So we found that that camera was the best of the cheaper range of hyperspectral sensors that we looked at. And we've since continued to work with that camera. And our hope is, as we carry this on into future work, to make it more and more automated end to end, so that farmers can finally get the nutritive characteristics readout that they want.
What's that camera used for in question without notice? What is that camera used for in normal day-to-day life? Like,
yeah. So a lot of the time we're working with sensors that we're not designed for an agricultural purpose. So if you take the Spectrum IQ camera, which is the hyperspectral camera we've worked with as an example, that one, well, can be used for anything really. The manufacturers don't specify, but they do suggest, for example, it's useful for traceability of foods. So for example, if you had 2 apples and you weren't sure what varieties they were, you could use the camera to tell you if they were the same variety or if there was differences. Or you could point it at a tray of strawberries and see if one was rotten or something like that. So there's so many potential uses of a camera like this, and we're simply taking a generic tool and trying to suit it to an agricultural purpose. And that's actually the same with a lot of the sensors that we've used too. Like, for instance, the sonar sensor that we use probably was originally imagined to be put in a factory, detecting, say, like passing parcels along a conveyor belt or something like that. And the UAV, probably more originally intended for building surveying and other tasks. So lots and lots of examples where we've repurposed sensors that were generic initially.
yeah, wow. So what nutritive characteristics are you able to read?
Yeah, we've actually focused on 8. These 8 we think are the most useful and common for ration software that dairy farmers would be using to try to create a balanced ration for their animals. So we've been looking at crude protein metabolizable energy, the 2 fiber fractions, ADF and NDF, water-soluble carbohydrates, non-fiber carbohydrates, and also dry matter, basically moisture, which is a nutritive characteristic per se, but is important to know. And I guess what we found is that you can predict some more accurately than others. So something like protein, which the chemistry of protein is, quite well known. It's all about the nitrogen bonds, and it just so happens that these sensors are able to pick those up really well. So protein is often one of the best predicted parameters. However, when we look at something like fiber, which is sort of like a lot of different molecules, it can be different compositions, and there can be a lot more noise when you're trying to pick up fiber in the plant. So fiber is an example of something that's actually quite hard to predict. So yeah, it does range.
Excellent. So basically what you're looking at doing is changing where farmers, if they're interested in knowing what the quality is of the forage that they're working with, they go out, you have to take a pasture cut or a cut, you put in a bag, you send it off to the lab, you wait a couple of weeks, by then you've grazed that paddock and you've moved on, and that's starting to regrow. So the results then are very close to useless. You're trying to get it that it's more instantaneous. Can you get instant results? Is it possible?
Yes, yeah, absolutely. Wouldn't it be great to be able to be proactive rather than basically reactive to your nutritional information? I see that hopefully farmers will eventually be able to use these technologies to make on-the-day decisions. First, understanding the nutritive characteristics of the pastures available, and then sending the cows to specific paddocks, for example. At the moment, you're asking, is there instant results possible? We're probably not quite there yet with the sensors that we have, but it's definitely our goal to work towards that. I mean, realistically, because these sensors were, as I mentioned before, generic off-the-shelf products for some other purpose, they don't really come with like data pipelines for the back end that just immediately gives you your results in terms of protein and fiber. We as researchers basically have to fill in that gap and be the middlemen to translate that raw information from the sensor into the agricultural information that farmers want to know. And we haven't yet completely automated that process end to end, but it is definitely on the cards for our future work, something we're really keen to continue pursuing. And ultimately, just manufacturers of these devices will likely be looking and seeing the potential for better and more intuitive sensors in this place. Now we've shown that they definitely work. It's likely the industry itself may take up that challenge and create the perfect end-to-end sensor that's just specific for nutritive information.
Yeah, perfect. So how do you see farmers using this sort of technology? So we're not just nutritive, but probably also the biomass work that you started out doing to make more profitable decisions. How can you see that working?
Yeah, so I think especially in the nutritive space, I would see that there's a lot of room to improve thinking about pasture as basically one component of a total ration that you're feeding your cows. And if you think about, say, people who do feed TMRs, they will know the exact nutritive concentration of every single component of that TMR exactly, and build their ration to have an exact amount of overall nutritive quality. And in the same way, I'd like to see that these nutritive sensors are basically enabling you to do that and fill in the value for what your pasture, the nutritive characteristics of the pasture are going to be, and basically create that ration and send your cows to the paddock that best matches those overall nutritive requirements that you have for the diet. And in the same way with biomass, I think it's all about picking the right paddock to go to and using your resource efficiently, and even allocating it in the right place, like putting a fence line in the right place in the paddock, having taken into account where the pasture is high and where the pasture is low. There's I would say a lot of efficiency improvements that could be made in terms of feeding efficiency through those kind of practices, definitely.
Excellent. So just thinking practically on farm as to how some of these could be applied, is the nutritive stuff in particular something that could be used to read silage quality? I mean, silage is something that we're always telling farmers, buy on quality, you need to have quality silage for your summer period. And is this something that could be used there in the future?
Yeah, I would definitely say so. It's not actually something that we have been looking at in our research project, but the background of these technologies, they're all essentially portable near-infrared spectrometers, and near-infrared spectrometry, or NIRS, is actually the exact same technology that people are using in the labs when you do send off your silage for a lab test. So there's really no reason why, if something's going to work for grass, it wouldn't work for silage, but it's the job of the researcher to sort of go out and build a big calibration set, and then basically find the model that teaches that sensor how to turn that spectral reading into a nutritive quality readout. But yeah, there's been so much work on NIRS as a technology and silage in the past that I think that would be very plausible. Yeah.
Watch this space, in other words, Anna. So Liz mentioned before that you haven't done, plot work with this. You've done bigger stuff. So how do you know, have you taken this technology on farm and tried it, or is it only been paddock size? How big have you taken it?
Yes, all of our work's been on working farms. So all of the models that we've developed and all the field work calibrations that we've collected have been fitting in amongst that standard daily activity on farm. So no curated beautiful plots here, just fitting in with the daily schedule. We've always worked at multiple paddocks across multiple farms. We had 21 partner farms throughout the project over time, and that was all for biomass. That we had a few less for the nutritive characteristics, but even so, they were all working farms. So I think we can say that they do fit into a real farm environment.
Yep, and you're able to get real results, Liz.
Real results.
Excellent. Something we always want. So if you've been able to prove that it works on whole of farm, how is it that farmers might be able to use this technology going forwards? Like, is this stuff farmer ready now, or is there still a step between now and when we'll see it actually on farm?
Yeah, so there's sort of a couple of we tested so many sensors that actually they're all at different stages. So and different stages for biomass and nutritive characteristics. So a couple of examples that I could give for biomass, I'll let Anna speak to the nutritive characteristic samples. But for example, the sonar sensor. So it's simple and effective. We've shown that it works. As we've spoken, we've used just off the shelf technology, but our particular framework and mechanism has been quite scientifically we've used that sort of scientific perspective, so highly accurate logger boxes and all that sort of thing. So even though we've proven that it works, it would actually need some more refinement to get to the farmer level for that particular technology. For the satellite work, that's sort of an alternative example. This is something that's ready to go. We've used all of our ground data collected across all of our farms. We've got really accurate and robust biomass estimates, and we can calculate them automatically every time we get a cloud-free image now. So that's a completely opposite example. And I mean, they both show that they give an example sort of an on-farm farmer using technology example, and then an off-farm information view coming in. And it's really that off-farm information view coming in where we've actually developed some extra digital products. So pushing the outputs through an application, for instance, an app. So, and that sort of started just because it had to during COVID times when we needed to get information out to farmers, but we couldn't actually get to them. We developed a prototype app at that time and sort of to push our information back to the farmers, and it's got a lot of attention and momentum, and so now we're progressing into a second stage prototype with that.
Oh, cool. Before I'll come back to that app, Anna, did you want to just talk about how ready the nutrient sensors are for farmers?
Yeah, I think the ones we've been working with, possibly the sort of technologies could be 5 to 10 years from being absolutely farm ready and well utilised and uptaken. But we're so close, and there are new sensors coming to the market every day, which make the process more streamlined, quicker and easier and cheaper as well. So it's not far off. And because we're providing all that proof of concept, hopefully manufacturers just see the value in this space and keep bringing out more and more useful versions of these sensors for farmers.
Yeah. Excellent. So a little bit of time. Let's not get too excited. Is that what we're trying to say here?
We're close.
Yeah, close. Yeah, so far. Okay, so Liz, you mentioned the app, and I always like hearing that because it is something that as someone as I've talked to farmers, I've heard about it. App development is not something that I am across, and I'm sure it's not easy. So do you just want to talk us through where the app is at and, what we might expect to see going forward?
Yeah, okay. So first and foremost, taking research products, even one that is automated and pretty well defined in sort of research terms, to that commercial always on 24/7 delivery is a massive undertaking. And I have learned so much over the last 2 years. like, honestly, I wish I'd known half of it when we started developing this prototype further. It truly is a huge undertaking. Having said that, though, it's something worth investing the time and energy into learning, because I think now that I know what I know, it's important that people in the industry create applications for the industry. You don't just get sent something that's not real, not defensible, and doesn't give you what you need. So it's a different perspective that I have now. But in terms of what we've learned to develop it, so there's, the volumes of data that you're talking about, moving from just 21 lovely partner farmers to potentially hundreds, thousands, it's different. You have to think in completely different ways, setting up all of those data connections, contracting, software developers. I've learned a whole new language and so many different software programs just so that I can talk to software developers, for instance. Subscription services, understanding what that means, and all of the data privacy assessments. Like we absolutely don't want to have anyone's data have any kind of issues like we've seen in the news recently. So, I mean, all of that stuff, it takes time and energy. So the app has been heard about a lot and you haven't seen a lot, and that's why to generate something that is always on, always reliable. You can be sure that your data's private. You can be sure that we're capturing and delivering what you want. It takes time to build. So, and the key learning I've had recently is that if you get one opportunity to get this to market, when we were testing the prototype, there was lots of clunky, glitchy bits in it, and people, they didn't like it, and they were happy to tell us, and I'm always happy to get that feedback. But when you go to that real next level of a commercial app, you've got one chance before people switch off. So that's another sort of interesting sort of marketing sort of idea that I've got now in my head. So I mean, our aim is to be just one of those apps that just catch on immediately, but because they've got the right science behind it. It's trustworthy. It does what you want it to do. It looks good. It's easy to use. So on the moment right now, we're really at the pointing end of doing a whole lot of user testing. So if it just, if it's not obvious what that button is, or if it's not obvious where to go, then it's not good enough and we try and fix it. So we're getting there, and it's been a huge journey.
Excellent. Now, I'm sure there's going to be lots of questions about this app, Liz, but we might park it there because for the minute, we will come back to them, everyone, I promise you. But we honestly, I feel like we could spend an entire webinar talking about this app and everything that's gone into it. But what we really need to focus on around this is that the research that's going into the back end of this app is something that is a leap forward in forage measuring and management for the longer term. So yeah, did you either of you two want to comment about that? Yeah,
look, I really absolutely want to just reinforce what an amazing job the team has done, and the work that we've done at Pasture Smarts. Obviously I'm biased, but it's transformational. We've completed a massive amount of work, assessed a full range of sensors, looked at biomass and nutritive characteristics, collected almost 4,000 samples in biomass alone. And I think it was close to 800 for alternative species recently. And that's meant that what we've created is robust, defensible models so that can work on real farm environments. And I mean, not only that, we publish all of our work in a range of journals. So it's been a full research program and very much transformational work. I'll let Anna comment too.
I think I just couldn't agree more. It's often easy to look at the outputs as being the shiny apps and so on, but the real output has been the work gone into the calibration of the sensors, and that has been a huge undertaking, and what has made all of these shiny outputs possible. So.
Yeah. Beyond the app, is there ways farmers might see this technology becoming available to them in the near future?
So from Pasture Smarts, not directly, but there's sort of other ways that you can influence sort of technology change.
I think even if you just think about the models that we've created, so all the pasture samples goes into a modeling effort, and it's these models that allow the raw output of sensors to be turned into useful information. Just that calibration data set alone is hugely valuable. Those models might in the future go on to be taken up by industry and actually used, to make these sensors that immediately give you the output that you want. So I think there is, and not only that, but also just the knowledge that we've gained on how to use sensors on your farm, what fits best with the farming practice, in what scenario do you want to do this or this, and hopefully just some of those things are just going to help farmers ease that transition into this new digital age by making sure they're making sound investments in technologies that are actually going to work for them. So I think there's so many ways that we do our work is going to be really influential, both now and in the future. Yeah, it's not just the outputs, but the knowledge gained.
Yeah, excellent. So what we might do, we might just remind everyone at this point in time that they can pop questions in the Q&A chat for us to see. And I see there is a couple that have been popped in there already. While people are thinking about questions and typing them in, one question. We've talked about these commercially available sensors. We haven't talked about dollars. How expensive are these sensors? Before you get us all too excited.
I mean, it really does range quite significantly. One thing I just want to say is that we mostly try to situate all our work in things that farmers were likely to eventually use. We tried not to ever work with something that we thought was completely out of the price range of farmers. That said, the sort of technologies we've used have ranged from below $1,000 in the case of, say, our sonar sensor, up to about the $30,000 range for some of our more fancy hyperspectral cameras and that kind of thing. And the UAV work, they come in somewhere in the middle. So something like the satellite, it's worth mentioning that the satellite data feed is actually free, but there's still going to need to be the middleman of the app to translate that data feed into the farmer's information. So these, I don't know if you want to comment on what kind of price point that might be.
Yeah, so the idea is that it'll be a subscription kind of scenario, as most apps are. We're doing a whole lot of work still to try and match it to basically return on investment on farm. It's not intended to be a huge money maker. It's about providing real investment for those users. So, and essentially to make it self-sustainable, just enable the support of all of that back end middleman work, as Anna put it.
Yeah, excellent. And I feel like one of your middlemen may be joining us in Farhad. And if anyone would like to know what he does, the latest innovation news features Farhad. So you'll have to make sure you read the innovation news. So the app being developed, one of the questions that's in the chat there, how is what is being developed by you in the Pasture Smarts project different to something like pasture.io, which is currently live, and there are a few farmers I know using it, or even Pastures from Space, which is CSIRO based?
Yep. Yeah, sure. So pasture.io is the closest thing, competitor, I suppose you'd want to say, now I'm in the marketing world, because it's targeted for dairy farms. The difference that we have, the predominant difference, is that Pasture Smarts is map-centric. It all starts with the farm map and incorporates that from that way in. The IO is much more of a dashboard scenario. We've done a whole lot of work in the background to try and limit as much as possible all of the farmer interactions that have to be made into the application, so that it's sort of less time entering data and more time getting some information out. But I mean, the biggest spruik I have is for our research background that's going into it. So the information that's being delivered into the app is is defensible. We can prove all of our accuracies and all of our estimates and show where they work and where they don't work and where you trust them. And that's really uncommon in the area. CSRO, Pastures from Space, is actually a broadacre focus on that particular work. It's not designed for dairy farms, and it wouldn't, in my opinion, work particularly well in a dairy situation.
But that is one of the things, and I'm going off track and we've still got some questions there, but one of the things with satellite data has been getting that small enough pixel, I think is what I'm after, for dairy paddock size, because when you're talking broadacre, your paddocks are huge, could be, you know, the size of some of our dairy farms, whereas you're looking at much smaller paddocks on a dairy farm, and you're wanting that individual paddock data, really, aren't you?
Yeah, exactly. I mean, however, there is a trade-off, and no matter how good the image looks, you actually want it to be accurate, and you want it to be comparable from today and tomorrow. And so that's, and I mentioned the sensor that we're using is free, and so it's not the highest resolution sensor at all. There are many more on the market that give you better resolution. But in terms of the accuracy of those predictions over time, which is really what makes the money for you, it's not always good to have the prettiest picture. Yeah. You want the real information.
Yeah, exactly. So one of the questions here is, and it's probably something we didn't go into, was just exactly what the methodology was used to calibrate, particularly for the satellite. Did you do pasture cuts or ground-based sensors or samples in the paddock? How did you go about doing that?
Yeah, so we, throughout the whole project, and all of the sensors that we've used have used the same sampling ground data collection to calibrate them all. So we actually have been able to cross-validate all the sensors with each other. So they've all relied on a destructive cuts at the quadrant level across multiple paddocks on many farms. Like I said, 7 in our calibration set, an additional 14 in our validation set, over many years, at least one full calendar year for the calibration. So capturing all seasons on irrigated dryland farms. So the destructive cuts were we took fresh weights, we dried them, obviously had dry weights. And most of the calibrations we've just immediately gone straight to that correlation with the dry matter as measured from destructive cuts. We took a lot of observations as well for all of those additional variables where we needed them, but essentially we want dry matter. So that's what we've built all of our models on.
And maybe I can just add to that as well, is that we were using RTK GPS that was locally corrected with the CauseNet correction, just to make sure like we were in the exact, within 2 centimeters accuracy in the exact position of the pixel on the Earth. So that we weren't out, like the pixels here and we're sampling over there. So yes, we did use like the most accurate RTK GPS technology to enable all of this sampling. And that's another reason why it's really important from that research perspective that we do this in a really highly accurate way to get the best possible results.
Yeah, and that's just answered the next question I was going to ask, which was how did you match the pixel with the ground measurement to make sure it was all accurate? So thanks, Anna. Well done. Excellent. Okay, regarding biomass, are we at the stage where a drone can be sent around the farm to measure dry matter of each paddock? Oh gosh, wouldn't that be wonderful? Instead of walking them. And can technology also measure weed percentage and bare earth, as mentioned before? Oh, that's a good one.
Do you want to take that one, Liz, or shall I?
It's near and dear to your heart, isn't it, Anna, on that moment?
Yeah, I'm flying drones early this morning. Yeah, so I guess what I would say on that is that we do still need a pilot to fly the UAV at this stage. Definitely I can see a market for UAVs. They're a bit more autonomous, essentially just going to set paddocks, doing their thing, coming home to charge, and then going to the next one. I think there might even be 1 or 2 products on the market that are starting to do that sort of space. But at the moment, we're still relying on a pilot to go out and fly the drone over the area of interest, which does, of course, require a little bit of time. But I think I see that becoming more and more automated as time goes on. We're just not maybe quite there yet. In terms of can the technology measure weeds, it's something that we've always collected in our data set. Every single time we've taken a quadrat cut is how much percentage of the earth was in that quadrat cut, and also how much was the percentage of weeds. It's not been a big thing for us to focus on actually calibrating the sensor for those things yet, but the good news is it's all actually there in our data set, and we could turn our hand quite easily to calibrating for those things as well, and see how that goes. So it's something that we've kind of passively enabled as we've gone along, and yeah, we'll see what the future brings. I don't know if you want to add anything to that, Liz.
Yeah, no, I think you've given some good practical outlines. In addition, the actual number of bands and band widths and regions that those sensors have on them is really the key. So the drone is sort of enabling technology to have the right sensor on it. So that would be my plea and suggestion, is that it actually will rely on having the right sensor on that drone.
Yep. Excellent. And then we might make it the final question and we'll wrap up. Did you explore the use of radars in conjunction with optical sats? So I'm assuming that's satellites.
Yeah. So we're still in the mix doing that. I should have mentioned it in my suite of sensors. So we're right at the pointy end now of sort of settling on our outcomes from that radar work. It is, for anyone, it's another example of an active sensor. So even though it's on a satellite, it's still emitting a radar wavelength, and measuring the time that it gets back and the actual frequency and amplitude of that return signal. So it's a more complex task to use, but we certainly are looking into it. Yes.
Excellent. All right. Well, thank you, Liz and Anna. I always enjoy chatting with you both, and hearing how, what you're doing and how we can speed up our forage measurement and understanding exactly what we're feeding our cows into the future. So that's fantastic. If anyone would like further information about Pasture Smarts, you can check out the DairyFeedbase website, dairyfeedbase.com.au. But there will be a follow-up email in which I'll include the link to the DairyFeedbase website, which has not only the information about the Pasture Smarts project, but also the other projects that are happening within DairyFeedbase. And I'll also include in that the link to the recording from today's session. This is our second webinar of the year, and the plan is to have one every 2 months covering off on different projects from both Dairy Bio and DairyFeedbase. And at this stage, I'm looking at doing something from the Dairy Bio Forages program for the next webinar, which will be in June. So if you'd like to be part of that webinar, keep an eye out. You'll get an email letting you know when you can register, but also keep an eye on the Dairy Australia events calendar, as it will be popped up there once we've confirmed who we're going to talk to. And as I wrap up, we just should note that Dairy Bio and DairyFeedbase are a joint venture between Dairy Australia, Agriculture Victoria and Gardner Foundation, who fund all of the research. So thanks heaps, Liz and Anna, and thank you everyone for joining us, and we'll see you all again next time. Thank you.